Assalamualaikum and good day. Our group, the squad team, will be presenting our test document on robotic system, control center and my bot. To start off, I will present the test plan. As you can see, our group consists of 6 members and 3 of them is the test analyst, 2 is the test leader and 1 is the test manager. So the purpose of this test plan is to detail the activities required to prepare and conduct the system test, and also to communicate to all responsible parties of the task that they are to perform. And the scope is, it will only cover the black box functional testing, which is control center function 01 until 06, and then my bot function 01 until my bot function 06. For the details of the test plan, you can see that this is the table for the traceability metric with the function, the risk level, the function description and also source of function. We also listed the features that we will be testing, which is status, notification, control mode, detection, diagnosis and connection. For my bot is movement and avoidance, special action, sensing object detection, images and videos, emergency notification and error detection. All of them have a high risk level. Features not to be tested is configuration, because this test plan is to configure the device connected. The approach that we will be using is equivalence partitioning, boundary value, decision table testing, state transition testing, and use case testing. And the item pass and fail criteria is all test case must be passed and no deadlock during operation. For the test management, we have planned several activities and tasks to be conducted to complete the testing within a specified date. So it starts with test planning and control, test analysis and design, test environment, test implementation, documenting tests, and documenting test closure, and also test complete. Next is the hardware and software that will be used during the conduction. Here we have listed each of the group member name, their role and responsibility toward the group. We have also estimated the testing schedule so that we will be able to deliver the testing within time. As you can see, test implementation and execution take the longest because it needs to execute all of the test cases that has been designed. And here is the risk and contingency. To make it easier, we have listed down all of the function with its risk description, likelihood, impact, risk exposure, treatment plan, and people response. Lastly is the metric list, glossary, and also incident classification. I think that's all for the test plan. Thank you.
Hello. For my part, the test list requirement, the function I did is FCC006. In this function, there is 2 requirements. The first requirement, requirement TC006, requirement 1, and requirement 2. For my bot requirement, error detection, there is 4 requirements. Requirement 1, requirement 2, requirement 3, and requirement 4. For the test design certification, for function, for my function is the connection function. In this connection function, there is 3 techniques being used. One is use case testing, decision table testing, and state transition testing. For my bot test design, for my bot test design, my function is error detection. The two techniques used in this test design is state transition testing and decision table testing. For the test case specification, the connection test case, there is 3 connection test case, which is the main flow, connect my bot use charging station, connection alternate flow invalid serial ID, the connection alternate flow invalid charging station. For my bot test case, there is only one test case, which is the necessary action if an error occur during the test for my bot. There is 4 input for the test case. That's all for me. Thank you.
My name is Muhammad Ashraf bin Muhammad Malik, metric number CB19005. Today I will be presenting the function for control center and my bot. My function for control center is notification and my bot is image and video seeding. This is the test case specification for notification. I have 2 test cases, that is main flow and notification log view. This is for image and video seeding specification. This is the main flow. This is the test cases for the main flow of image and video seeding. This is the alternate flow for capture image and video, send image and video, and for real-time image and video. Lastly, for viewing angle. For test design specification, in notification, I use state transition testing and decision table testing. This is my notification state transition diagram. I have 6 state and using 6 test case of coverage. For decision table testing, there is 8 decision test case of coverage, and this is the notification decision table for decision table testing. For test procedure specification, in notification for control center function, for this test procedure to achieve, the control center must get notification about anything related to my bot. This is the notification main flow for notification test procedure. For image and video specification test procedure, the prior for the execution is the my bot must be turned on. This is the main flow for image and video seeding. Checks obstacle, capture image and video, send image and video, and able to sign live preview about the emergency. That's all for me. Thank you.
Hi, my name is Muhammad Alif Akmal bin Muhammad Nazri. My ID is CB19008. My function for control center is detection, and function for my bot is sensing and object detection specification. For test case design specification, function number 4, which is detection, it has 2 techniques are identified for designing these features. The first one is use case testing, and the second is state transition testing. This is the table for use case testing, and this is the table for use case test condition and coverage. The second is state transition testing. This is the table for state transition testing. And this is the table for detection test coverage. And for my bot function in test design specification has 2 techniques that are identified for designing this test feature, which is state transition testing and decision table testing. This is the state transition testing diagram, and this is the table state transition testing. State coverage table for this MyBot function, and this is the decision table testing. In test case specification for function detection, it have 3 test case, which is one TC-CC004001 for detection main flow. The second test case is TC-CC004002. It is for detection alternate flow error on sensor status. And the last one is TC-CC004003 for detection alternate flow turn off detection alert. For function MyBot, which is sensing and object detection specification, has only one test case, which is the ID is TCMB03001. It is for the main flow. For test procedure specification, detection test procedure have 3 test procedure ID, which is the first is detection main flow, the second is detection alternate flow error on sensor status, and the last one is detection alternate flow turn off detection alert. And for MyBot is sensing and object detection specification test procedure, has only one test procedure ID, which is TPMB003001 is the main flow. Thank you.
So for the list of requirements, I'm going to start with the first function of control center, which is status indicator. There are 4 requirements in total. The first one is control center must be able to display MyBot status. Second one, control center must be able to display MyBot GPS location in real time. The third one, control center must be able to receive notification and display MyBot health status in real time, with whether it is healthy or malfunction. The fourth one, control center must be able to display MyBot connection, whether it is online or offline. As for the first function for MyBot, which is gate motion, there are 9 requirements in total, which is a lot. So the first one is the walking step motion. The second one is MyBot shall be able to walk at the rate of at a certain rate according to the mode. And the third one is MyBot shall be able to switch mode. Fourth one, MyBot must be able to detect if it is in unbalanced position. The fifth one, MyBot shall be able to activate fall recovery special motion if it falls over. The sixth one, MyBot shall be able to avoid obstacle. Seventh one, it is left side of the obstacle has more clearance area, and there are certain requirements MyBot move to the left side of the obstacle and vice versa. The eighth one is MyBot shall be able to climb 30-degree slope, and the last one is that MyBot shall be able to stop and maintain current position if it receives stop signal from behavior controller. Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Munirah Shamsuddin with measure ID CB19011. So now I'm going to present the test design specification for robotic system that covers control center and MyBot. So this is the first version of the test design specification, and it was released on 25th of October 2020. So moving forward to the first function that need to be tested is the status indicator for control center with ID FCC001. So 2 techniques are identified for designing this test feature, which includes use case testing and state transition. So in this function, control center actually must be able to display the correct MyBot status. Whenever MyBot change from one mode to another, so control center must be able to update its interface and display the correct status of MyBot. So to test that particular function, we have used use case testing and state transition testing. As for MyBot, the first function that need to be tested for MyBot is the walking step motion. So there are with ID FMB001, MB indicating MyBot. So previously CC indicating the control center. So 2 techniques are identified for designing this function. To test this function, we have used the equivalence partitioning and boundary value analysis. So in this function, my bot must be able to walk in a valid walking step motion, which covers from 10 centimeter to 50 centimeter, not more and not less. Now I am going to explain the test case specification for robotic system that covers control center and my board, and this is also the first version of the test case specification. Okay, for the first function, which is for control center, which is the status indicator, there are 6 test cases in total. The first one is the test case for status indicator main flow, and the second one is for the status indicator alternate flow for when my board is in low battery. The third one is for the alternate flow too, but for when charging error occurred. The fourth one is when surveillance error occurred, and the fifth one is the return error occurred, is the test case for when return error occurred, and the last one is for when the surveillance mode is deactivated. As for my board, there are 4 test cases in total. The first one is for the 9 cm walking step motion. The second one is for 10 cm walking step motion. This is the valid value for my board walking step motion, and this is the invalid one. And the third one is also the valid one, which is 50 cm, the test case for my board walking step motion. And the last one is for 51 centimeter, which is also an invalid value, same as the 9 cm. Moving forward to the test procedure specification, which is also the first version and also covers control center and my board. For the first function, which is a control center status indicator function, there are a total of 6 test procedure, each indicating the flow in the use case testing. The first one is the status indicator main flow test procedure. Second one is the status indicator alternate flow test procedure. The third one is the charging error test procedure. The fourth one is the surveillance error test procedure. The fifth one is the return error test procedure, and the last one is the surveillance mode deactivated test procedure. As for my board, the first function for my board, which is the walking step motion, there are only 1 test procedure that all of the procedure for the test has been combined in 1 test procedure table. So this is the only test procedure table for walking step motion my board.
Hi, Assalamualaikum. My name is Nur Amira Aisyah binti Mahathir with matric ID CP19006. For the list of requirements, the fifth function of CC control center, there are 3 requirements. The first requirement, CC must be able to retrieve my board battery level that will be indicated in battery percentage level. And the second requirement, CC must be able to retrieve my board battery health that will indicate by healthy for normal and change for malfunction working battery. And the third function is CC must be able to retrieve my board sensor status that will indicate by normal for normal and error for abnormal. For the fifth function of my board, there are 3 requirements. For the first requirement, my board should be able to detect fire using infrared camera. And the second requirement, my board should be able to detect flood using its water level sensor. And the third requirement is my board should be able to check if there are moving heat signature. Then my board shall sound an alarm and turn on light. For the 3 function, my board shall automatically send an alert signal to CC with the current GPS location, picture and video. The 2 techniques that I use for test design diagnosis is use case diagram, use case testing and state transition testing. The first testing is use case. This is the use case diagram for diagnosis. From the use case diagram, we got the test condition and test coverage. The second testing that I use is state transition. This is state transition for the diagnosis. From the diagram above, we got the state table for the diagnosis. And from that, we also got test coverage. So the second function is emergency notification specification. The test design that I use is use case and state transition. This is use case diagram for the emergency notification specification. And from the use case diagram, we got 4 test condition and test coverage. The second test design that I use for emergency notification specification is state transition. This is state transition diagram for emergency notification specification. From that diagram, we came out with a state table. And from the state table, we got 4 test coverage. From the 4 test design that I have created, we got test identification. For diagnosis, I got 2 test case. For the first test case is for main flow, and the second test case is for the alternate flow. For emergency notification specification, there are 4 test cases, which cover the main flow and also alternate flow. There are 2 test cases for diagnosis. The first one, the input is click on diagnosis menu tab. The second test cases is click on the refresh button. While for emergency notification specification, there are 4 test cases. The first test cases, my bot will check the fire, the flood, and the moving heat signature, while the second test cases only to check the fire using infrared camera. The third test cases, my bot will detect flood using water level sensor. The fourth, my bot detect there are moving heat signature or not. For the test procedure, the diagnosis have only 2. The first one is the main flow procedure, and the second one is for the alternate flow unable to display battery level. Emergency notification specification test procedure only have 2 also. The first test procedure will explain the main flow, and the second test procedure will explain the alternate flow for detect fire, flood, and intrusion.
As for me, I've chosen the control mode for CC function and special action function for my bot. So the list of requirements, there is actually 4 requirements for control mode. The first one is CC should be able to start upon connection or after it has been stopped by return or stop command. It should also be able to stop and cease all action and enter either mode. CC should also be able to stop all tasks and return to charging station. And then CC should also be able to order my bot to enter surveillance mode, in which my bot will only move to its designated location. Next is the my bot special action requirement. Okay, there is 5 requirements. For the fall recovery, upon detecting robot not in upright standing position, my bot shall send and store GPS location of the my bot. And for moving object, my bot shall be able to grasp object with maximum weight of 2 kg. And for the battery power and health alert, my bot shall be able to update and monitor the mission controller regarding my bot's battery power level and health. And for the inability to return to charging station for more than 10 minutes, my bot shall stop moving and hibernate. And for signal loss, LTE network shall be selected at all times, or if it is not selected, my bot shall attempt to regain the signal. So next is the test design specification. For control mode, I have chosen the state transition testing technique and decision table testing technique. So as you can see from the diagram, it starts by starting the my bot, moving to designated location, stopping all activity, charging the battery, and shutting down based on their own input. And from this diagram, I can derive a set transition table, and then finally I can make the test coverage, which is for the control mode. I have made 10 test coverage to cover all of the function. And next is the decision table testing, which is I have created the 13 test condition, and then I've used this test condition to create the control mode decision table. As you can see, there is start mode, surveillance mode on, surveillance mode off, stop mode on, and I've used the condition up here to test it using the decision table. So as for the special action function, since there is too many requirements to be covered, I have chosen to specifically cover the last requirement, which is the LTE network signal loss. I've also chosen the state transition testing and decision table testing technique for the test design specification. So it starts by starting my board, sending data and storing GPS location, overwriting all pre-programmed command, and continuing with current command. And from this diagram, I can derive a state transition table. And lastly, I can come up with the test coverage table. And I've come up with 6 test coverage for this function. And also decision table testing, I have created the 8 test condition and used these 8 test conditions, such as my board not in upright position, my board in upright standing position, 3 seconds in stable standing position, and I've used this condition to in the decision table to test the data. And after I have done the test design, I have identified that there is 8 test cases that can be derived for control mode, and also 5 test cases that can be derived for special action function. Now for the test case specification, I have created 8 test cases that can cover all of the control mode function. For example, the first test case is start on, so the expected result is my board is started. And the second one is surveillance on, so my board should actually move to the designated location. And the third test case is surveillance off, so expected result is my board move to the designated location, send all pre-programmed detection and real-time video to CC. And for the special action function, I have created 5 test cases that can cover all of the function. For example, the first one is my board is not in upright standing position, so expected result, behavior controller send data and store the GPS location in mission controller. Second test case is my board is in upright standing position, so expected result, my board shall continue its current command. Now is the test procedure specification. So for the control mode test procedure, there is 2 test procedure that can cover all of the 8 test cases. So the first test procedure is the control mode main flow. The setup is to turn the start mode on, turn the surveillance mode on, turn the stop mode on, and turn the start mode off again. This test procedure covers 4 test cases. Next is the second test procedure, which is the control mode alternate flow. The setup is to turn the start mode on, surveillance mode on, turn the surveillance mode off, turn the stop mode on again, turn the stop mode off, turn the return mode on, and turn the return mode off. So this test procedure covered 4 of the test cases. So now is the special action test procedure. There is 3 test procedure to cover all of the 5 test cases. So the first test procedure is for the for recovery main flow, where you can see that setup is starting the my board not in upright standing position, send data, my board still not in upright standing position, and override all pre-programmed command, my board is in 3 seconds stable standing position, and continue the current command. Second test procedure is for recovery alternative flow 1, start my board and my board is in upright standing position, and continue the current command. And the last test procedure is for recovery alternative flow number 2, which is start the my board not in upright standing position, send data, still not in upright standing position, override all data, is in less than 3 seconds stable standing position, send data, and my board is in upright standing position, continue the current command.
For our group test summary report for robotic system, control center and my board, this is our document control. Okay. The reference number for the test summary is RS-DSR_1. The version history for our code document is 1.0.0. The test summary report. The test summary report, we provide a summary of the finding based on test log. The document reference is the RS_TP_1.0. Second document reference RS_TDS_1.0. The third document RS_TCS_1.0. The fourth document RS_TPS_1.0. The fifth document RS_TL_1.0. For test coverage completeness, we can refer at the table below. The test plan, test design specification, the test case specification, test procedure specification, test log specification, and also the test summary. It shows that all the document has been completed. The result of the summary: the item tested was the function in robotic system 1.0.0. The test was conducted at squad laboratory and office. 46 has been conducted and 100% of the incidents has been deferred until the next release. The fatal defect found are considered high risk and must be fixed before product release. The product will be retested after defect has been fixed to ensure that all defect has been addressed. If there is no incident raised, it is expected that the product has conformed to the SRS document version 1.0.0. Rationale for decision: due to the existence of open defects at the end of the test iteration, the team suggests those defects are fixed prior to release. Existence of fatal defect signifies high product risk. The conclusion and recommendation. The conclusion is the current product is not fit for release until fatal defects are fixed. The recommendation: a more thorough login check on the system and reduce similar defects in the future. That's all for the summary. Thank you.